Hello everyone, my name is Kevin Tarr. I am an iOS engineer and today is day 26 of Algorithms in Swift. So today we're going to be focusing on linked list. This is classic and traditional computer science, linked list, okay? Um, a linked list is a data structure that focuses more on node reference and it's not purely limited to contiguous memory blocks in memory or contiguous data in memory, much like an array or a set would be considered to be contiguous. All the indexes and elements of its space and memory are held next to each other, kind of like Lego blocks. Versus a linked list is scattered all across memory, and each node has a reference to the next node and the next node and to the next node until we get to the end node. It has a start node and then traverses through all of its nodes to get to the end node. Okay, well, that's a basic, I think, a pretty precise way to explain how they're stored in the memory linked list. But we're going to be solving. We're going to be dealing with a problem that deals with all 26 letters of the alphabet, and we're going to be assigning those letters to nodes and trying to get to the end of it. So this is going to be a pretty interesting problem. And if you went to school for computer science, this will be a trip back down memory lane, nostalgia. Let's begin. Okay, guys, so before we begin our problem, I want to just make one more mention of the difference between arrays and linked list in regards to their actual time complexity, okay? So when it comes to several methods, arrays and linked lists have different time complexity. For instance, if I want to insert an item in the middle of an array, that's order n complexity because depending upon how large the array is, that determines how many elements the array is going to have to push down and push upward in order for the element to be inserted at a specific index in the array. Versus a linked list, since nodes are scattered all over the memory, by putting an item, let's say, in the middle of a linked list, all you're doing is changing the previous linked list pointer to point to the new item's reference point, and changing the current item's reference point to point to the next node that the previous node was pointing to. So all you're doing is changing directions of the pointers, okay? Of the previous and the current one. Everything else stays the same. Now, if you're trying to do something like find a very random position in the array, that's extremely fast. That's order one complexity. You know, it goes fast. It goes the same speed no matter how large the array is. Versus a linked list, you have to start from the beginning and go through. Let's say I'm trying to find the index or the value of the end node. I have to go through every single preceding node before the end node in order to get to that. You know, so that is a difference between arrays. That's sort of a base level understanding of sort of the time complexity difference between arrays and linked lists with certain functions. Okay, so with this problem, we're gonna have to be pretty extensive. We're gonna have to create two classes, and we're gonna create a for loop to traverse through the nodes. Okay, don't be intimidated by this. I think this is can be straightforward. I'm gonna try my best to explain it as we go along. Okay. Let's begin, guys. So we're going to call this class linked list node. We're going to make it a generic class. And we're going to give it a generic value. And then we're going to create its next pointer to be of linked list node type optional in case the pointer is nil. The next node is nil. And then we're going to init with a generic parameter and give it a value of itself. Okay. Then we're going to create another class called a linked list class, and we're going to create a linked list node. We're going to call it a start node, and that's going to be of linked list node. Generic. And then we're going to create a function called printing nodes. And then we're going to call this current node. It's going to be equal. We're going to assign the value of start node to current node. Then we're going to do a while let loop, and we're going to do some type safety with checking to see if the current node is nil. Basically, this adds the current node is nil. If it's not nil, we're going to assign the value to node. If it is nil, we're going to stop the while loop. Okay. Print. That's just Swift's type safety at hand. Swift. Swift. Sorry. Print node dot value, and we're going to add a space between every letter. Okay. And then we're going to assign current node, the next node's next pointer value to current node. Okay, that's complete. Okay, so both our classes are complete. Now let's just create some variables before we create our for loop. So var is going to be list equals linked list, and we're going to assign, in the mystery here, and assign this to be a character class. So now we're done with generics. Okay. For our purposes here, then we're going to create a previous class, a previous linked list node. It's going to be of character as well, but we're going to equate it to nil. Okay. Now we're going to do a for loop for letter and A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay. We're going to, I'll make it optional. We're going to let node equal linked list node value. It's going to be the letter value. Then we're going to do some type safe unwrapping. If previous node equals previous, if let, then previous equals previous node dot next pointer. Okay. Else, previous next pointer equals nil. Sorry. Else, previous equals node, and previous equals list dot start node. Okay, and then previous equals node. Okay. I'm sorry. List dot start node equals node. Okay. And then we're just going to print our nodes. We're going to do list dot printing nodes. Okay. And this should print out every letter of the alphabet. Yep, we got every letter of the alphabet here. Okay. So basically, we did a while loop, check to see if the node was nil while it's for looping, and if the node was nil, if the node was not nil, we printed out the value and directed the next current node to be the next node and the next node, and that's going through the for loop until we reach the end of the for loop. And throughout the for loop, we're checking if the previous node is nil. If it's not nil, then we make the next pointer equal to node here in our for loop. And if it is nil, that means we haven't started our node, our linked list, or traversing yet. So we assign the start node to the node, and we go through the list. We add we assign node to previous as well if it has no value, and then we're printing all the nodes here. Okay.